Hello, my dear students. A very warm welcome to all of you in Shri Jain Rank Zone. I am your friend and mentor for the subject Business Economics. In this lecture, we'll continue with Chapter 3, that is Theory of Production and Cost, and in particular, we'll continue with Unit 2, that is Theory of Cost. All the concepts will be covered in the coming series of lectures. So let us begin now. This is lecture number 7. The first concept that we are going to discuss today is short run average cost. Short run average cost. Short run average cost. The first topic that we are going to discuss today is average fixed cost. Average fixed cost. The formula to find average fixed cost is total fixed cost divided by quantity. AFC is obtained by divided the total fixed cost by the number of units of output produced, that is AFC equal to TFC by Q, where Q stands for unit produced, stands for units produced. Thus, an average fixed cost is the fixed cost per unit of output. There is an instance, if a firm is producing with the total fixed cost of 2000 rupees, when output is 100 units, the average fixed cost is 20. That is 2000 divided by 100. That is total fixed cost equal to 2000 divided by output, that is the quantity is 100 units. So 2000 by 100 equal to 20. And now if the output increases to 200, the average fixed cost will shift to rupees 10. That is 2000 divided by 200 units equal to rupee 10, average fixed cost. I believe you understood. Since total fixed cost is constant amount, that is 2000, average fixed cost will fall as output increases. Therefore, we can say that we draw an average fixed cost curve. It will slope downwards throughout its length but will not touch the x-axis, as AFC cannot be 0. That means what? Average fixed cost cannot be 0. I believe you understood till here. So over here we can say that TFC remains constant, irrespective of increase in quantity. Increase in quantity produced, denoted by the capital letter Q. So AFC is inversely related to quantity. That means as output, that is Q, increases, AFC decreases. AFC decreases and vice versa. And vice versa. AFC curve will not touch, AFC curve will not touch the axis, since AFC cannot be 0. We had just seen this. I believe it is clear till here. Let us continue and see average variable cost, that is AVC. Average variable cost is found out by dividing the total variable cost by the number of units produced. Average variable cost equal to total variable cost divided by quantity, where Q is the number of units produced. Thus, average variable cost is the variable cost per unit of output. Average variable cost normally falls as output increases from 0 to normal capacity output. due to occurrence of increasing returns to variable factors. But beyond the normal capacity output, average variable cost will rise steeply because of the operation of diminishing returns. The concepts of increasing return and diminishing returns have already been discussed earlier. Let us see figure 10 about variable cost curve. It will first fall, then reach to the minimum and then rise. Figure 10. Average variable cost. First it is falling, then will become constant, and average variable cost will start increasing. Just see it properly. Average variable cost in figure 10. It will first fall, reach to the minimum and then rise. First fall, reach to the minimum, started rising again. Started rising again. Let us continue. Average variable cost, just write over here. Up to normal capacity of output, AVC decreases as output increases. Output increases, so AVC decreases. Due to what? Due to initial increasing returns. Increasing returns. Stage 1. Beyond that, beyond normal capacity output, AVC will rise steeply. Due to what? Due to the operation of diminishing return. Just see it over here. Rise steeply. AVC will rise steeply due to diminishing returns. AVC is not exactly U-shaped curve. Somewhat it is U-shaped, but not exactly. You can say AVC curve will reach to the minimum and then rise again. Okay? Let us continue with average total cost. Average total cost, which is also known as average cost. Average cost, AC. Average total cost is the sum of average variable cost and average fixed cost. So average total cost equals AFC plus AVC. It is the total cost. It is the total cost divided by the number of unit produced So average total cost equal to total cost divided by Q. Average total cost is equal to total cost divided by Q. Here it is T, ATC. Of average total cost curve depends upon the behavior of average variable cost curve and average fixed cost curve. In the beginning, both AVC and AFC curve falls. Therefore, average total curve will also fall sharply. When AVC curve begins to rise but AFC curve still falls steeply, ATC curve continues to fall because during this stage the fall of average fixed cost curve is greater than average variable cost curve. Just see it over here. Average fixed cost curve is falling, average variable cost is rising, but still average total cost curve will fall only. Why? Because the average fixed cost curve is falling very steeply, and over here that is why average total cost curve will fall. This is stage 1. But as output increases further, there is a sharp rise in average variable cost curve which offer more offset the fall in AFC. Therefore, average total cost curve first falls, reaches to the minimum and then rises. Thus, we can say that average cost curve is a U-shaped curve. It's a U-shaped curve. Okay. Just write in the initial stage average cost will decline sharply due to fall in average fixed cost curve. AC curve will reach to the minimum and then rise again due to increase in average variable cost, and obviously AC curve is a U-shaped curve. Let us continue now. The next concept is marginal cost. The next concept is marginal cost, that is change in total cost. So marginal cost is the addition made in the total cost by production of one additional unit of output. In other words, we can say that it is the total cost of producing 1 unit instead of T unit instead of T minus 1 unit. Whereas T is the any given number. Supposingly it is the producing 5 units, 5 minus 1, that is 4 units. So that is an additional unit from 4 to 5, that is written as T. For example, if we are producing 5 units at a cost of 2000 and now suppose the 6th unit is produced and total cost is 250, the difference in cost is 50, then the marginal cost is 50 and marginal cost will be 24 if 10 units are produced, because the total cost equal to 320 minus 200 equal to 3 divided by 10 minus 5. It is to be noted that marginal cost is independent of fixed cost. This is because fixed costs do not change with output. It is only the variable cost which change with the level of output in the short run, and therefore we can say that marginal cost is in fact due to the change in variable cost. Symbolically it is written as follows. Marginal cost equal to change in total cost divided by change in quantity of output. Or we can say that MCN minus TCN minus TCN minus 1. MC 6th unit equal to total cost at 6th unit minus total cost at 6 minus 1, that is 5th unit. Total cost at 6th unit minus total cost at 5th unit. Supposingly total cost at 6th unit the MC is 250 and total cost at 5th unit MC is 200. The marginal cost is 50 for one additional unit, and that is 6th unit. One additional unit, and that is 6th unit. Marginal cost curve falls as output increases in the beginning. It starts rising after a certain level of output. This happens because of the influence of law of variable proportion. The marginal cost curve becomes minimum corresponding to the point of inflection on the total cost curve. The fact that marginal product rises first, reaches to the maximum, then declines ensures that the marginal cost curve of the firm decline first, reaches to the minimum, and then rise. In other words, we can say that marginal cost curve of a firm is U-shaped. The behavior is shown in table 2. Just see the table 2 marginal cost curve, but before that just take some notings. Marginal cost per unit equal to difference in total cost divided by difference in quantity, that we have seen in the example also. Marginal cost declines initially, reaches to the minimum, and thereafter increases. Okay, MC is a U-shaped curve. MC cuts AC from below when AC is minimum. At this point, MC cuts AC from below. Okay, just see this table now. See this. We have plotted units of output 0 to 12. Total fixed cost 1000. Variable cost is plotted. Total cost, fixed cost plus variable cost equal to total cost. Fixed cost plus variable cost is total cost. Average fixed cost is total fixed cost divided by quantity is average fixed cost. Average variable cost, total variable cost divided by quantity. Average total cost divided by quantity, and marginal cost, change in the total cost. So TCN minus TCN minus 1, change in the total cost. I believe you understood how to solve it. For instance, just see at point 4, fixed cost is 1000, variable is 196, 1196, average fixed cost 1000 divided by 4 is 250, average variable cost is 196 divided by 4, 49, average total cost, so total cost 1196 divided by 4, it is 299, and marginal cost is 380. So as you can see, marginal cost, where is total cost? Over here, 1196 minus 1140, 1196 minus 1140, that is 56. I believe it is clear. Just see one more instance at 12th unit, 1000 plus 1080, 2080, average fixed cost upon 1000 divided by 12, 1000 divided by 12, average fixed cost, average variable cost, total variable cost divided by 12. What is total variable cost? 1080 divided by 12, you got 90. Average total cost 2080 divided by 12, that will give you 173. And this 300, that is 2080 divided by 1780. We got what? 300. We got what? 300. I believe you understood. It is clear what we have concluded from the above table. Just see, the above table shows that fixed costs do not change with the increase in the output up to a given level. Average fixed cost therefore comes down with every increase in the output. Average fixed cost will come down with every increase in the output. Just see it over here. As output is increasing, average fixed cost is falling. It is falling. Variable cost increases, but not necessarily in the same proportion in the increase in output. In the above case, average variable cost come down gradually till 4 units. Thereafter starts increasing. So it's possible. Talking about the marginal cost is the additional cost divided by additional unit produced. This also comes down first and then starts increasing. Let us continue and let's see the relationship between average cost and marginal cost. The relationship between average cost and marginal cost. The relationship between marginal cost and average cost, that is MC and AC, is the same as that between other marginal and average quantities. The following are the points of relationship between the two. The first, when average cost falls as a result of increase in output, the marginal cost is less than the average cost. When AC falls as a result of increase in the output, MC is lower than AC. What we need to remember over here is, you can write over here, when AC falls, MC is lower than AC and MC curve is lower than AC curve when AC decreases. When AC decreases. Understood? Let's see the second point now. When average cost rises, when AC rises as a result of increase in output, the MC is more than AC. You can write over here, when AC decreases, MC is greater than AC. MC curve rises steeply than AC. Understood? And the third one, when average cost curve is minimum, marginal cost, that is MC, is equal to AC. In other words, you can say that MC cost curve cuts average at the minimum point. Just write over here, when AC is minimum, AC equal to MC, MC increases slightly earlier than AC. MC curve cuts AC curve when AC is minimum, and MC curve cuts AC curve only from below and not from above. Is it clear? Okay. Let's continue with our next topic, and it talks about long run average cost curve. Long run average cost curve, that is LAC curve. Long run average cost curve, LAC curve. Just try and understand it well. As stated above, long run is a period of time during which the firm can change all types of its input, whether it is a fixed input or variable input. The change is possible. In other words, whereas in the short run, the firm is tied with given plant, in the long run, the firm can build any size, any scale of the plant. Therefore, we can move from one plant to another. It can acquire a big plant if it wants to increase the output or production, and small plant if it wants to reduce the output or production. The long run being a planning horizon, the firm plans ahead to build the most appropriate scale of plant to produce the future level of output. It should kept in mind that once the firm has built a particular scale of plant, its production takes place in the short run only. Briefly put, the firm actually operates in the short run and plans for the long run. Long run cost of production is the least possible cost producing any given level of output when all individual factors are variable. So in the long run, we have learned that all the individual factors are variable. A long run cost curve depicts the functional relationship between output and the long run cost of production. Just try to understand from here. In order to understand how the long run LAC cost curve is derived, we consider three short run average cost curve, and these short run average cost curve is known as SACs, are called plant curves. In the short run, the firm can be operating on any short run average cost curve given the size of the plant. Suppose that there are the only three plants which are technically possible. Given the size of the plant, the firm will be either increasing or decreasing the output by changing the amount of variable inputs. But in the long run, the firm chooses among three possible sizes of plant as depicted by short run average cost curve SAC1, SAC2, SAC3. In the long run, the firm will examine which size of plant or which short run average cost curve should be operated to produce a given level of output so that the total cost is minimum. It will be seen from the diagram that OB, just see the diagram, OB amount of the output, the firm will operate on SAC1 curve, OB amount of output, the firm will operating at SAC1 curve, short run average cost curve 1, though it could also produce SAC2 up to OB amount of output. The production is on SAC1 and as a result in lower cost on SAC2. For example, if the level of output is OA is produced on SAC1, it will cost AL unit if it is produced on SAC2. See it over here. OA like here. Continue. Similarly, if the firm plans to produce an output which is larger than OP but less than OD, then it will not be economical to produce on SAC1. For this, the firm will have to use SSE2, and similarly, the firm will use SSE3 for output larger than OD. See it over here, OD, SSE3, and not SSE2, SSE3, because at SSE2, the average cost is rising, as SSE3, the average cost is still falling. Clear? It is clear that in the long run, the firm has to make choice in the employment of plant, and it will employ the plant which yields minimum possible unit cost for providing the given output. Short run average cost curve, long run average cost curve. By numerous small SSE curves, you can derive a long run average cost curve like this. SSE 1, 2, 3, 4, 5, 6, 7. You can derive a long run average cost curve. See the Y U-shaped long run average cost curve. Why the average cost curve, the long run average cost curve, LAC curve is U-shaped? As has been seen in the diagram, LSE curve is a U-shaped curve. This shape of LSE curve has nothing to do with U shape of SSE, which is due to the variable factor ratio. Because of the long run, all factors are variable. So U-shaped LSE arises due to increase returns to scale. As discussed earlier, when the firm expands, return to scale increases. After a range of constant return to scale, the returns to scale finally decreases. On the same line, we can say that the LSE curve first declines and then finally rises. Increasing return to scale causes fall in the long run average cost, and decreasing returns to scale over here results in rise in the long run average cost. Falling long run average cost and increasing economies of scale result from internal and external economies of scale, and rising long run average cost and diminishing returns to scale results in internal and external diseconomies of scale. So the long run average cost curve initially falls and increase in output, and after a certain point of time make a boat shape. The long run average cost curve, LSE curve, is also called a planning curve of the firm, as it helps in choosing the appropriate a plant on the decided level of output. The long run average cost curve is also called envelope curve because it envelopes or supports a family of short run average cost curves from below. The above figure depicting the long run average cost curve is arrived on the basis of traditional economic analysis. It is flattened U-shaped. This type of curve could exist only when the state of technology remains unchanged. But empirical evidence how modern times face L-shaped cost curve over a considerable quantity of output. The L-shaped cost curve, long run cost curve, implies that initially when the output is increased due to the increase in the size of plant, per unit cost falls rapidly due to the economies of scale. Long run cost curve does not increase even after a sufficiently large scale output, as it continues to enjoy economies of scale. Okay. Write some notings about long run average cost curve. The long run average cost curve. A long run average cost curve that is LAC depicts depicts the functional relationship between output and the long run cost of production. Cost of production. Next, no distinction, no distinction of fixed as well as variable. This means all factors of production are variable in long run, and hence we can say that every cost is variable. The distinction between fixed and variable cost does not arise in the long run. Next point, LAC equal to least cost. LAC equal to least. Just write in the long run. Over here, the cost of production is the least for any given level of output as all individuals factors are variable. So a firm can move from one plant to another acquire a bigger plant if it wants to increase the output, and a small plant if it wants to reduce its output. Hence, we can say that average cost cannot be higher in the long run than in the short run. This LAC is the least cost combination for any particular output level. We have written 3 points. Point number 4, planning curve. Planning curve. LAC curve is called planning curve since the firm plans to produce any output in the long run by choosing a plant on the LAC curve. Corresponding to the given output. Thus, we can say that LAC curve helps the firm in the the size choice of the size of the plant for producing a specific amount of output at the least possible cost. Write a note over here that SAC, that is a short term average cost curve, are called plant curves and LAC curve is called planning curve. I believe all of you understood till here. Let us write one more note. This is in relation to derivation of LAC curve from SAC. So just write derivation of LAC curve from the SAC. When LAC curve is declining, then LAC will be tangent to the falling portions of the SAC curve. What is the principle applicable over here? The principle is returns to scale will first increase due to what? Due to internal and external economies so long run average cost curve will decline. Next is when long run average cost curve is rising. When long run average cost curve is rising, in that case, the long run average cost curve will be tangent to the rising portions of the short run average cost curves, SAC curves. What is the principle applicable over here? The principle applicable over here is returns to scale. That means what? Returns to scale will decrease later, and due to the internal and external diseconomies, limitations, and so we can say that long run average cost curve LAC will rise. Just write returns to scale will decrease later due to internal and external diseconomies. So, long run average cost curve LAC will rise. Thus, we can say that thus as a result of initial fall and subsequent increase in long run average cost curve, long run average cost curve LAC, it will be U-shaped. So LAC curve will be U-shaped curve. Okay. Just see this curve once again. This is short run average cost curve, SAC curve. Over here, why we have chosen L? At point OA, we have chosen L and not H because L is lower than H. At point OA, why have we have chosen H? Because at SAC1, because point L is lower than point H. If I talk about point OB, in that case, we have chosen Q. If I talk about OC, we have chosen K because this K is lower than J. And at point D, why we have chosen R? At point D, why we have chosen R? Because R is on the SAC 3. So we are not choosing R which is there on SAC 2. We will choose R for SAC 3. We are choosing K for SSC 2 and we are choosing L for SSC 1. I believe you are clear till here. Because we need to reduce the cost and that is why we are doing so. Just see it over here in average cost curve, in the long run average cost curve. We have SSC 1 to SSC 7. And over here we are at OM point, we are choosing F because it is the lowest cost. At ON we are choosing K because it gives the lowest cost. At OV we are choosing H because it is giving lowest cost. At OQ P is giving lowest cost. At OW T is giving lowest cost. and that is why if I combine all the lowest cost or short run average cost curve, I'll get what? The long run average cost curve. I believe you understood this. Let's take a quick recap what we have done today. In today's class, what exactly we have done. So we began with short run average cost curve. We seen the average cost curve. We had seen the average variable cost curve. We had seen average total cost curve and the relationship between average total cost, average variable cost and average fixed cost. We shifted to marginal cost, the relationship between average cost and marginal cost we have done precisely. Then we shifted to long run average cost curve. In long run average cost curve, we have seen short run average cost curve and long run average cost curve. And I try to explain you why the LAC, that is the long run average cost curve, is U-shaped. It is in reality it is U-shaped. The long run average cost curve is in reality it is U-shaped. And then I given you the notings in relation to long run average cost curve, LAC. Point number 1, 2, 3, 4, and there is a note, that is the derivation from LAC from SAC. This is based on the diagram, the two diagram which we have seen ahead. So here I wind up this class. We'll be continuing with this lecture with the same chapter in the coming lectures. Thank you.